Good morning, class. So, let's have written a test, so this lesson will be a bit shorter. We are busy with functions, correct? Okay. The functions, you guys had homework, I'm sure? Are these the sums for homework? Huh? Right. So we are doing the intercept method already, no? Alright, so we spoke about drawing the graphs and all of those things. This was the first graph we drew, not so? And you know that the graph is drawn with a smooth curve and all of those things. And the graph is symmetrical about this axis of symmetry, not so? No? You all okay with that? Last year we drew these graphs on a program and showed you, not so? Okay. So you guys have an idea, it's a smooth curve and all of those things. No? So now we're going to look at a couple of questions, or what we call the interpretation of these graphs, reading values off from these graphs and things like that. That is why I also asked you to leave space for questions pertaining these graphs. Okay. So we're going to go straight into it. And it's dealing, most of these things we have done last year anyway. Okay, so it's just a refresher as well. So let's just move this graph over a bit. Alright, so this is graph 1. Alright. So the first thing we're going to be asking ourselves is with regards to the domain. Domain and the range of the graph. Okay, that's number 1. Then we're going to look at where the graph is increasing. Okay? Increasing and where the graph is decreasing. Then we're going to look at the turning point, the coordinates thereof, if it's maximum or minimum, and the value of x, the maximum value and minimum value, and the value of x at which it occurs at. Then we're going to look at the axis of symmetry, the equation thereof. Okay? Okay, this is behind it first. Let me just pull it over a bit first. Then put it back afterwards. Okay. The equation of the axis of symmetry. Then we're going to ask ourselves, number 5, where is f of x equal to 0, where f of x is less than 0, and where f of x is more than or equal to 0. Okay? Then we're going to speak about the equation of f of x if it's reflected firstly in the y-axis, secondly it was reflected in the x-axis. Okay? Then number 7, we're going to look at the average gradient, and I'll speak about this later on, the gradient between x is equal to 1 and x is equal to 2. Okay? Yes? Any confusion so far? Okay, so we're going to ask all of these questions for every graph we are going to be drawing. Okay, so it's quite a bit. I'm not going to write it down all the time. So I want you guys to write it down. And for the parabola, we're going to be asking ourselves these questions all the time. Okay. So every one of those graphs that we're drawing, we're going to do the same interpretation type question. Okay. Can I move it over now? Just check here. Alright. I'm going to put it here in the corner because I would need all the space to write on. Okay. Right. First things first, the question is with regards to the domain. So what can we say about the domain of this graph? What is domain? For possible x values. So what do we know about this graph? It's going to negative infinity, not so? And positive infinity. Which means to say, it's all the values. So how do we represent that? So for the domain, we say x is an element or real numbers. What's the range? The range is all possible y values. Does this graph exist at negative infinity? No. Where does it start existing at? Negative 8 onwards. Not so. So what do we say for that? Y must be more than or equal to negative 8. You all agree with that? Number 2. Increasing and decreasing. Increasing. Now, for increasing and decreasing, we always read from left to right. Can you see that? We're always moving from left to right. So what do we notice about this graph? As x increases, what happens to this graph? It's decreasing. Can you see that, people? So it's decreasing for x's less than. Up until which point does this graph decrease? Till an x value of 1. So it decreases for x's less than 1. Can you see that, people? So it is decreasing for x's less than 1. Decreasing for x's less than 1. And where's the graph increasing? Sorry, it's decreasing for x is less than 1. So what do you notice on this far side of 1? The graph is increasing. Can you see that? So it's increasing for x's more than 1. X is more than 1. Alright, let's look at number 3. Number 3 says the turning point. What's the coordinates of the turning point? 1 and negative 8. So what can we say? Does this graph have a maximum or a minimum value? It has a minimum. Alright, it has a minimum value of negative 8 and occurs at x is equal to 1. Remember we did this in when we did completing of the square, and this way it fits in as well. Okay. Number 4. What's the equation of the axis of symmetry? The equation of the axis of symmetry. X is equal to 1. Number 5. Where is f of x equal to 0? Where is f of x? Was it less than and equal to 0? Alright, let's look at those two. So where is f of x equal to 0? We know that f of x is a y value, not so for the function. Where is the function equal to 0 is? Where it's basically cutting the axis, the x-axis. You guys understand? So where is the function equal to 0? The function equal to 0 at x equal to negative 1 or x equal to 3. Okay. Then the question is, where is f of x less than or equal to 0? So in other words, that has to be below the line. Not so? With less than or equal to 0. So it's less than or equal to 0 all along here. Can you see that, people? It's always less than 0 from negative 1 till 3. Can you see that? Is this continuous or breaking solution? It's continuous. So the inequality will be written together. Does it make sense? So when we write that as an inequality, Check this out here. We say x must be greater than negative 1 but less than 1. Does the graph exist at negative 1? Yes. Does it satisfy this condition? Yes. At 1? So not at 1, sorry, at 3. Yes. Okay. Next question. Where is f of x less than 0? No, more than 0. Is that what I asked then? Where is f of x more than 0? So in other words, is where it is above this line y is equal to 0. Not so? So if you look at where the graph is above, it's this part here, there and there. It's a continuous or a breaking solution? It's a breaking solution. Not so? So in other words, x must be less than negative 1 or more than 3. You guys understand? So we say x must be less than negative 1 or x must be more than. Okay. Just remember, to draw these graphs is 4 marks. And all the other marks come from interpreting the graphs. Okay. Answering questions with regards to the graphs. Okay. Then the question says the equation of the reflection. The first one was the reflection in the y-axis. Reflection in y-axis. What's the rule if something is reflected in the y-axis? X becomes negative. Remember we did this last year as well. Right. The reflection in the y-axis, x becomes negative. So what was the equation of this graph? Y equals? What was the equation of this graph, people? 2x squared? 2x squared minus? Minus 6. So if x becomes negative, then it's y equals 2 times negative x squared minus 4 times negative x minus 6. Wherever I see an x, I put the negative x. So negative x all squared is positive x times 2 is 2x squared. Negative 4 times negative x is positive 4x minus 6. Okay? Are you all okay with that? Any confusion? Nothing? Right. Number 2. The second question was the reflection in the x-axis. What's the rule if something reflected in the x-axis? Y becomes negative. Not so? Now coming back to this equation, y equals 2x squared minus 4x minus 6, the y becomes negative. So it's negative y equals 2x squared minus 4x minus 6. Divide throughout by negative, so it's going to be negative 2x squared plus 4x plus 6. Okay. Next question is the average gradient. Now, looking at the average gradient, there's a note on, let's just get the page number for you, which you can go and read the average gradient. You can get a deeper understanding into average gradient. Also, average gradient is important because it leads into calculus, which we'll be doing next year. Okay? Calculus. Okay, that's on page 166, speaking about average gradient. So when you do the explanation they're given is that when you're given a straight line, okay, say we are reading on page 166 now, okay, so we are told given a straight line y is equal to 2x minus 4, y is equal to 2x minus 4. This graph, the straight line, has a gradient of 2. Not so. So anywhere along that curve, the gradient is 2. You guys understand? What is gradient? Gradient is basically the slope of the graph, or the inclination of the graph. Not so? Right, so on a straight line, the gradient will be always 2. Then we are told that the gradient of the linear function straight line remains constant. To calculate the gradient of the straight line, we use the formula m is equal to y2 minus y1 over x2 minus x. We know that. Not so? That's your equation for the gradient. Changing y over changing x. So delta y over delta x. The same thing. Then we are told that the straight line graph of the form y is equal to mx plus c, where m is greater than 0, the graph is an increasing function. When m is positive, the graph is increasing. When m is negative, the graph is decreasing, and so on. Okay? If m is equal to 0, okay, then the equation is y is equal to x. So if m is equal to 0, so if you've got y is equal to mx plus c, and m is 0, then the equation is just y is equal to c, whatever c is. So if c is positive, it will lie above the line. If c is negative, of course, it lies below the line. That's when your gradient is 0 there. Then we are told that if m is undefined, then k is equal to x. Okay. So if that's undefined, remember when your gradients are undefined, the line is actually parallel to your y-axis. So it will have a constant x reading there. So if that is x is equal to 6, then the equation of that line is x equal to 6, or that point was 6 there. Okay, but that gradient in that case is undefined. So if the gradient is 0, parallel to your x-axis. Okay, if your gradient is undefined, it will be parallel to the y-axis. Okay, a non-linear curve. Now non-linear curves is curves that are not linear. Linear things are, or linear curves are straight lines. Not so. So non-linear curves is non-straight line curves. Not so. And what are examples of non-linear curves? Parabolas, hyperbolas, exponential graphs, cubic graphs, which you will get. And all of those things are non-linear. So linear is straight lines, non-linear is the other graphs that we are doing. Okay. So a non-linear curve such as parabola does not have a constant gradient, which means to say that gradient is not the same all along. Like if we take it from this point and that point, you see that gradient here, if I must draw a line through there, that gradient there is going to be different to the gradient I'm going to draw here, or calculate here. Can you see that, people? However, we know that this gradient is going to be negative, and this gradient is going to be positive. Okay, but we'll speak about that now again in our calculation. This is again a non-linear curve, such as parabola does not have a constant gradient, but we can calculate the average gradient of that curve. The average gradient of the curve between 2 points is the gradient of the straight line joining those 2 points on the curve. That's what I see this stated now. Okay. A function is increasing if the variables change is the same direction. Okay, the function is increasing if the variable change is in the same direction. Okay, so basically, if it comes to be positive, which means to say positive divided by positive is positive, or negative divided by negative is positive. Not so. As long as the gradient results in a positive, it is a increasing average gradient, or the graph is increasing between those points. However, if it's now different, the graph will be a decreasing function, which means to say the gradient is going to be negative. Okay. Then we're told to look at page 137 for the increasing and decreasing. We spoke about that already. A function is decreasing the variable. Okay, so we spoke about that as well. Okay, so you guys have an idea of what the average gradient tells us. So look at it again. What does average gradient tell us? It tells us about the gradient between 2 given points on the curve. That's all he's doing. Okay. So you guys okay with that? So let's do the calculation. And this calculation is normally 4 marks or 3 marks, depending on, at that point, what is calculated. Okay. So it's fairly simple. So number 7, for the average gradient, we gave the average gradient between 2 points, which is x is equal to 2, which is here, 2, and x is equal to 1. So the average gradient, we want to know what's happening here. If I drew a line going through those 2 points, what would the gradient of the straight line be? That is what we're interested in. You guys understand? So what we do is we say, okay, we work what f of 1 is. We know what f of 1 is because we work with it already. It's going to be negative 8. Not so. What is f of 2? So wherever we see an x, we put a 2. So it's 2 times 2 squared minus 4 times 2 minus 6. Work that out. Alright, so what do we get? Negative 6. Okay. So what's the coordinate? Okay, that coordinate we know is 1 and negative 8. And this coordinate would be 2 and minus 6. Not so. So what we do is we say for the average gradient, normally follows a formula, f of b minus f of a over b minus a. It's the same as you say y2 minus y1 over x2 minus x1. It's exactly the same. Yes, you may. Okay. But I'm writing it down, so if you're picking up another textbook or somebody else explains, you know where it's coming from. Okay. And that's the format normally given. Okay, it's just f of b minus f of a over b minus a. So if we do the change in y with change in x here, what does this give us now? If this is a, then that of course is f of a. Can you see that, people? If this is a b, then that of course is f of b. So what we have here? Negative 6 minus 8 over 2 minus 1. So minus 6 plus 8 is 2 over 2, sorry, over 1 is 2. You all got 2. So what does that tell us? That tells us that the gradient of this line is going to be 2. Okay? Otherwise, they could, what the question around that is, normally follows that, not normally, but seldomly follows. They will ask you, what does that answer tell us? You can answer by saying that the graph is, between those 2 points, the graph is increasing at a rate of 2. Okay, the graph is increasing at a rate of 2. Okay. Well, what would, if the answer was negative 2? Then it would have been the graph is decreasing at a rate of negative 2. Alright? No, decreasing at the rate of 2. If it's negative 2, the graph is decreasing at the rate of 2. If it's positive 2, the graph is increasing at the rate of 2. Absolutely correct, thank you. So if it's decreasing at the rate of negative 2, then it's actually saying it's increasing. So that's negative by negative. Okay. Let's do another graph. For homework, I would like you guys to answer these questions for those 4 graphs that I gave you for homework. Okay? Can you do that for me? Yes. Alright. I'm sure we won't have all the time to answer another question after this. Okay, so let's just run through it quickly. So the first question was domain and range. Okay. So domain. So what's my domain? All possible x values. Not so. So what is my domain with regards to this graph? Sorry? X is an element of all real numbers. Not so. Let's look at the range of this graph. What is range? All possible y values. So what's the range on this graph? Y is less than and equal to 8. Second question was increasing and decreasing. Okay, where's the graph increasing? The graph increasing or decreasing here? Increasing. So it's increasing for x is less than 3. Here the graph is decreasing. So it's decreasing for x is more than 3. What was the equation of this graph? What was the equation of this graph, people? Y equals negative 2 into negative 2x squared. Yeah? Minus 10. Did I give it to you like that? No. What is the form I gave it to you in? Y is equal to negative 2 open brackets x minus 3 squared plus 8. But what do you notice about this turning point? It comes from here. Can you see that? Oh yes. Okay. So if you look at these two graphs, number 3, what was the turning point of number 3? Negative 1 and negative 20. That's the turning point. Let us check if that's correct. Huh? Yes. Let's look here. What's the turning point here? Negative 1 and 20. What do you notice? The x is the additive inverse. And the y remains the same. So what will this one be without looking down? The turning point here. Negative 1 and negative 20. What's your turning point here? Negative 1 and? Can you see that? So if it's given in the form of y equals a into x. Are you okay? Why are you making so much noise? It was given in the form of y is equal to a into x minus p squared plus q. Your turning point would be positive p and q. Make a note there. Okay. So let's answer these questions quickly. Number 2. Number 3. What's the third question? Turning point. What's the coordinates of the turning point? Negative 3 and 8. What can we say about this? Positive 3, yes. What can we say about this? Graph has a maximum value of 8 and occurs at x equal to 3. Number 4. What's the fourth thing? Axis of symmetry. What's the equation of the axis of symmetry? X is equal to 3. Next. F of x equal to 0 where? At 0 and, at 1 and 5. This is negative 10 here. What is it again? X is equal to 1 or x equal to 5. This is where f of x equals 0. So where is f of x less than, what was it? Less than and equal to? Where is f of x less than and equal to 0? Is this part of the graph here? And that part. Is it continuous or break-in solution? Break-in solution. So in other words, x is less than 1 or x is more than or equal to 5. Not so. Less than and equal to 1. X is less than or equal to 1 or x is more than or equal to 1. Where is f of x less than more than 0? So in other words, we're going to look where it is above this graph of above your x-axis. Not so. So where is it above more than 0? It's from 0 till, it's from 1 till 5. Can you see that, people? It's from 1 till 5. Okay? Is it continuous or break-in solution? Continuous. So it's x has to be greater than 1, but less than 1. Okay? Let's look at number 6. What's the question number 6? Sorry? Reflection? Yes. Okay, so reflection in y-axis. What's the reflection in y-axis? what happens? X becomes negative. Not so? So if I go with this equation on the board, we say y is equal to x becomes negative. So it's minus 2 into negative x minus 3 squared plus 8. But normally when the first term is negative, I factorize the negative. Not so? Inside the bracket. So you take a negative out there, is negative 2 into negative x minus 3 squared, no, x plus 3 squared plus 8. Not so? Negative squared will always be positive. So it's negative 2 into x plus 3 squared plus 8. Okay? If something reflected in the x-axis, what's the rule? Y becomes negative. Not so? Now we say, again coming back to this equation, we have negative y is equal to negative 2 into x minus 3 squared plus 8. If I throw out one negative, so y is equal to 2 into x minus 3 squared minus 8. That's the equation. What's the next thing? Average gradient. Average gradient is the similar to the gradient. Not so? But f of one, we know already. F of 1 is equal to what? 0. We worked this out already, no? So this point is 1 and 0. Then f of 2. So we substitute 2 in, so that is 3. So 2 is going to lie here. 2 and some y value. Not so? So if we substitute 2 in, it's negative 2 into 2 minus 3 squared plus 8. So that's going to give us negative 1 squared positive 1 times negative 2 is negative 2 plus 8 is 6. So this point is 2 and 6. For the average gradient, what is the formula? F of B minus F of A over B minus A. Okay? So this should simply be, if this is A, that is F of A. If that is B, that will be F of B. You all okay with that? So what would we have? 6 minus 0 over 2 minus 1. Which gives us 6 over 1, which is 6. So what does that tell us? The graph is increasing at a rate of 6. You guys understand? So for homework, I would like you guys to do those 7 interpretation questions as well as last year you guys have dealt with hyperbola graphs, not so? Just check what is first hyperbola. You do for me exercise 5.6. Exercise 5.6 as well as 5.7. 5.6 and 5 is very, very important for tomorrow's lesson. Okay. People enjoy the rest of your day. Good morning, class.